In today's world, security is of utmost concern, owing to which the field of biometrics has advanced to a great extent. The human face is one of the most attractive biometrics as it can be acquired without the cooperation or knowledge of the subject. However, machine recognition of faces is a challenging problem as the appearance of a face significantly changes with illumination, pose, and facial expressions. Moreover, facial biometrics are comparatively less distinctive. Compared to still images, videos contain more information because of the additional temporal dimension. Motion also helps in the recognition of faces. This makes video-based face recognition one of the most viable options for surveillance applications. However, surveillance is a very challenging scenario for face recognition. Surveillance cameras have a wide field of view because they are required to survey large areas. Moreover, surveillance cameras are also meant to monitor activities rather than just focus on faces. However, the downside of a wide field of view is that only a limited number of pixels cover the human face, which is insufficient for machine recognition. Due to all these hurdles, the surveillance system implemented in today's world still lacks smartness, which means that a security guard needs to monitor the CCTV feed all the time, making the system inefficient. This human intervention can be bypassed with the help of the proposed solution. Instead of a person continuously monitoring the CCTV feed, a direct algorithm can be implemented to detect and recognize the face of the person entering the premises. If the person is not recognized, an alarm system is directly activated. Every system, though thoroughly tested, might give false alarms. The problem of false detection can be resolved by double checking. Instead of processing just one image from a series of frames and concluding on its basis, a second image is captured to give a closer view of the subject, which thereby helps in cross-checking the result from the earlier case. This second frame is selected when the camera is closer to the person, as a result of which the image is more detailed. The latter result is preferred as it would be more accurate. The proposed solution would not increase the cost to a great extent as it utilizes a system already in place with some minor additions in the hardware, but it would drastically improve the surveillance system. Although there are a few products in the market which use face recognition for the detection of intruders, none of them work in the real time and most of them are implemented on previously recorded video feeds.
Hardware implementation, microcontroller. The microcontroller board consists of an Atmega 16 dual-in packaged chip. The chip is clocked externally by a 16 MHz crystal oscillator that provides clock input. The microcontroller, as we know, has 4 ports consisting of 32 general-purpose input outputs. The controller is powered by a 5-volt supply given by the Texas Instruments PTN78060 variable voltage regulator chip module. LMD18200. Operating on supply voltages between 12 volt and 55 volt DC, the LMD18200 handles up to 3 amperes of continuous current. The switching power device is an H-bridge, hence it can control 2 motors at the same time. Because the switches allow current to flow bidirectionally, the voltage across the load and the direction of current to the load can be of either polarity. There are many ways to control the speed of motors, but one very simple and easy way is to use the pulse width modulation. LM555. The 555 is a single chip version of the commonly used circuit called multivibrator. The chip has various controls such as trigger, discharge, etc. The buzzer is driven by the output of the timer chip.
The first step of the system is a high-resolution webcam which gives the live video feed to the video processing system. While the system runs face recognition, the microcontroller simultaneously activates the motor. This moves the camera ahead using the rack and pinion assembly. Depending upon the final result, microcontroller displays the output on the liquid crystal display or activates the buzzer if an intruder is detected. The given demo has been divided into 2 parts. The first frame shows the camera movement depending upon the motion of the subject. As the subject moves ahead, the camera goes forward simultaneously. Face detection is done using HAR feature-based cascade classifiers and ADA boost. Database creation is a process that is achieved prior to the actual working of the system. It involves capturing still images of about 5 subjects with varying lighting conditions, poses, and expressions. Later, the significant features from every face are extracted using the method of eigenfaces and PCA. The face detected from the real-time video is compared with this database of eigenfaces using the method of k-nearest neighbors. In this method, Euclidean distance is calculated between every image in the database of eigenfaces and the image of the detected face, and whichever comparison yields in the least distance below a certain threshold is considered as a match. If the minimum distance is above the threshold, algorithm declares the person as an intruder.